Hello everybody, welcome back. As per usual, well, today's better. I'm only 20 minutes late. Absolutely destroyed. Yesterday I had some, let's say some TV series emergency, so gone up very late. So it's not to not get obsessed about stuff lately, but it works in alternate days. So as per, let's maybe get me the streaming manager here. So we can kill all of this. And let's keep on looking. I'd say we split it again like yesterday. So a little splits over here. Rust links. Very well. So we meant to go about the structs. 07 structs. Now I read a little bit about structs, so shouldn't be that. Wait. Oh yeah, I started this yesterday. So I read a little bit of structs, shouldn't be too bad. Now at the fields that test regular structs expects. So the regular structs. Yeah, it wanted I32, which is 0 should match, right? No such field, brother. Red, blue. Oh, the green is an N. Is it? Is a tuple struct. So tuples should be. God damn it. Does this work now? It doesn't. Well, I mean, I'm confused. So the struct should be struct user active bool. Okay, this looks pretty much the same. Yeah. Wait. Let's go a few sides. Not a problem. Red on color tablet structs. So there was this when collected, there were also the tuple structs. Yeah. Okay, so that's how you pointed out. Only the types. Which means I don't actually tell this anything. Instead say a regular struct. This is the tuple. I meant to say regular. Expect function tuples or tuple variant found color regular structure. Yeah, we fix that. Fine. So red, green. Yeah, it was a good idea to leave it for today because yesterday I was already out of it. Good, so this is the tuple struct. Well, I guess I don't need to save it. So it should be tuple struct, god damn it, color tuple struct, which we saw as O, 255 and O. Obviously I forgot the dynamic language brain and put the scope. And the final is instantiate a unit struct. Derive debug. Okay, I don't get the last one. That message Unix structs are fun. Can I restart this somehow? It's a unit struct. I mean, this is an empty one, right? For decoration. Can I restart this single reset current exercise? So let's say cargo run exercise 07 structs 1. Well, int list quit reset check all. So it won't print me shit. Yeah, I guess you can make one simple empty one. I believe I read that you can add the debug option to be able to print some standardized in some standardized way, which is fine, which is good, but I don't know what's the meaning of just getting something like this done. I mean, does it do much, or is it just out there? Like, what's the purpose of this particular stuff? But let's not get bogged down. We are at 31, so let's keep it moving. So. Now we have order, name, year, phone, mobile, email, item count. Okay, this would be like a database stuff, like a database query, let's say. Function create order template that returns an order. So Bob 2019 false false true item count 0. Okay. Let order template. So that's an order. Create your own order using the updated syntax and template above. Let your order template. Isn't it the same thing for before? Don't quite see how is this different. Oh, wait. I see. So this should be dot order template. And semicolon. So he wants a string, should be string from. Oh, nice. Now, hold up. This should work. Didn't it work? Test your order panic. Oh, because the count changed. Count 0 should be count 1. So this cool unpacking thing. Same with Go, but only and exclusively for for iterable stuff or arrays. So to be able to copy it like that, that's nice. That's actually neat. And finally, the number 3. So that contains data, but can also have logic. Oh, in this exercise we have defined the package struct and we want to set some logic attached to it. Ciao, ma. Hai tutto rimasto. Hai tutto rimasto. So sender string and u32 as a package. Implement packages. Okay, so that's how you attach a method to a type. It's good. Function new sender count 3. Okay, and it returns a self. If weight in grams is less than 10 distance, how should you handle errors in Rust? But we will learn about error panic. Okay. So if we have less than 10 weight, we don't return anything. Otherwise, we return the object itself. Adequate return type to the function signature. If is international, read the test unit and use the method to find out what package is considered international. Assert is international, so Package new from Spain or Russia. And we check sender country. This is a type package, which means signature should be package. And return self. So it's international if guessing this will be so Spain, Russia, and 1200s. Self. È finito. Volevo andare a comprarlo più tardi, sotto ne porto uno. So does the self let me see the method sender? Yeah. Okay, so if I guess that I can check if sender is from Spain. And self dot receiver is Russia. And self dot wait is 1200s. We should just return the self. Okay, one at a time. What's the big deal now? If maybe missing an else clause. But I don't want to. Okay, so I'm constructing it, I guess. Alright then. It is because of the borrow checker. I guess we can be fun over here. Can I just return this? And we say cool. Yeah, this works. Yeah, especially I overcomplicated stuff for no reason. Okay, so that's done. Add the correct return type to the function signature. Get fees, cent per gram. So there should be an int. And we get the weight in grams. So self dot weight in grams times cents per gram. Use a little arrow. Yeah, I don't follow why do we have why do we have to be so awkward with a semicolon and not have it sometimes? Just put it everywhere. Make it easy for everyone else. Enums. Now I've been curious about enums for a while. So enumeration type. When structs give you a way of grouping together related fields of data, like a rectangle when it's width and rough, enums give you a way of saying a value is one of possible sets of values. For example, we may want to say that a rectangle is one set of possible shapes. By the way, Mike's still on. A rectangle is a set of possible shapes that also includes circles and triangles. To do this, Rust allows us to encode this possibility as an enum. Let's look at the situation we might want to express in code and see why enums are useful and more appropriate. That's actually the case. Say we need to work with IP addresses. Currently, two measure standards are used for IP addresses, version 4 and 6. Because there are only possibilities for an IP address that our program will come across, we can enumerate all possible variants, which is enumeration gets its name. Yeah, see, I understand now what you say an enum is, but you can get an enum that's the same bullshit as that's the same name for the self selling variables in C. So this always gets awkward because I could, for the longest time I couldn't understand what people talked about. I didn't understand why enums are so good. We can enumerate all possible variants, which is where enumeration gets its name. Any IP address can be either 4, 6 addresses, but not both at the same time. The property of IP address makes the enum data structure appropriate because an enum value can only be one of its variants. Both version 4 and version 6 are still fundamentally IP addresses, so they be treated as the same type when the code is handling situations that apply to any kind of address. We can express this concept in code by defining an IP at a kind, enumeration, and listing the possible kinds of IP can be 4 and 6, v4, v6. These are the variant of enum, v4, v6. IP address now a custom data type that we can use somewhere else in the code. We can create instance of each of the two variables, if other kind like this. Okay, so you can select what I want. Note that the variant of enum are namespaced under its identifier, and we use a double colon to separate the two. This is just because now both values are at the same type, if other kind. We can then, for instance, define a function that takes any if other kind. All right. I had my coffee. Today sucks. And we can call this function with either variant route 4, route 6. Using enums has even more advantages. Think more about our IP address type. At the moment, we don't have any way to store the actual IP address data. We only know what kind it is. Given that you just learned about structs in chapter 5, you might be tempted to start this problem with this aspect. Enum struct kind address. Looks okay, but but since this is a bait, has to be a bait, so should probably be wrong. Here define a struct if address that has two fields, a kind field and a kind field of its type. If other kind, the enum we defined previously, and an address, the field of this type string. We have two instances of this struct. The first is home and has the value if other before as its kind with associated address data of 127.0.0.1. The second is loop back. So now variance. However, representing the same concept in just an enum is more concise rather than an enum inside a struct. We can put that data directly into each enum variant. This new definition of the if address enum says both 4 and 6 would have associated strings. So enum string let home. Okay. Attach data to each variant to enum directly, so there's no need for struct. Here it's also easier to see another detail of how enum works. The name of each enum variant that we define also becomes a function that constructs an instance of the enum. This is if address v4 is a function call that makes a string argument and return an instance of the if address type. When I get this constructor function defined as a result of the enum. Okay. There's another advantage of using an enum rather than a struct. Each variant can have different types and amount of associated data. Version 4 IP address will always have 4 numeric components that will have value between 0 and 255. If you want to store version 4 address as 4U8 values, we still express v6 address as one string value. We wouldn't be able to store in the struct. Enum handles this case very well. Great. We've shown several different ways to find the store values for version 6 IP address. However, as it turns out, wanting to store IP address and encode which kind they are is common that the standard library has a definition we can use. Let's look at how the standard library defines IP addresses. It has exact enum variants that we've defined and used, but it embeds the address data inside a variant in the form of two different structs, which are defined different for each variant. Struct snippet. Yeah, so you can add just a lot more. I see it. No. This code illustrates that you can put any kind of data inside an enum variant, string, numeric type of struct, for example. Not too much complicated than that. Now, even though standard library contains a definition of for if address, we can still create and use our own definition without conflicting because we haven't brought the standard library definition into our scope. We're talking about scopes. Let's look at another example of enum listing. So, message quit, move, write, change color. It has 4 variables: quit, move, write, change color. Defining an enum with variants such as one on listing 6.2 is similar to defining kind of struct definition, except the enum doesn't use struct, and all the variants are grouped together under the message type. The following structs could hold the same data as the preceding enum variants hold. Okay. These different structs, each of kind has its own type. We're going to use easily define the function. like any kind of messages we could with the message enum defined listing. There's more similarity between enums and stacks, just as we're able to define methods on using imp, we can also be able to define methods on enums. Here's a method call that we could define a message. Imp messages function call. So I can attach function, it's a function that gets me a type, and I can attach to it another function. Okay? Where a function would use self to get a value that we call the method on. In this example, we created a variable m that has the value message write string from hello, and that itself will be the body of the call method when the end call runs. Let's look at another enum in the standard library that is very common and useful option. The option enum and its advantages over null values. This section explores a case study of option, which is another enum defined by the standard library. The option type encode a very common scenario in which a value could be something or could be nothing. For example, if you request the first item in an empty list, we could get a value. If you request the first item in an empty list, we could get nothing. Expressing this concept in terms of the type system means that the compiler can check whenever you handled all the cases you should be handling. This function can prevent bugs that are extremely common in other programming languages. Programming language design is often thought of in terms of which feature you include, but the feature you exclude are important too. Rust doesn't have the null feature that many other languages have. Null is a value that means there's no value there. In the language with null variables can always be one of two states, null or not null. In this 2009 representation null referenced the $1 billion mistake. Tony Hoare, the inventor of null, has this to say. I call it my billion mistake. Yeah, I know this. The problem with null value is that you could try to use a null value as a non-null, not null value, you get an error of some kind because this null or not null property is pervasive. It's extremely easy to make this kind of error. However, the concept of null is trying to express is still a useful one. A null is a value that is currently invalid or absent for some reason. The problem isn't with the concept, but the particular implementation. As such, Rust does not have nulls, but it has an enum that encodes the concept of value being present or absent. This enum is option t, as defined by the standard library as follows: option t, none, or some t. The option t enum is also useful that it's even included in the prelude. You don't need to bring it into scope explicitly. Its variants are also included in the prelude. You can use some and none directly with the option prefix. The option t enum is still just a regular enum, and some t and none are still variant of the option t. Tutto bene? The T syntax is a feature of Rust we haven't talked about yet. The generic type, yeah. For now, all you need to know is that T means so it's use of option value types. Some number E, some number E, up number option I32. No. Ma tutto bene? Ok, ciao, buon lavoro. Certo. Ciao ciao. Okay, so the type of some number is option I32. The type of some char is option char, which is a different type, and Rust can infer these types because we specially by inside them some variant. For absent number requires us to annotate the overall option type. The compiler can infer the type that the corresponding some variant will hold, but only look at none value. Here we tell Rust that we mean for absent number to be of type option I32. We have some value, we know that the value is present and the value is held within some. When we have non-value, in some sense, it means that the same thing as null. We don't have a valid value. So why is having option t any better than having null? In short, because option t and t are different types. The compiler won't let us use option t value as if we were defining a valid value. For example, this code won't compile because you're trying to add I18 to option I18. If run this code, we get an error message like this. Intense. Uh, we cannot add option 80 to option I8 to I8. The trait add option 8 is not implemented for I8. Have the following. 18 as I8 as add. Okay, so you have to explicitly get the value. In effect, this error means that Rust doesn't understand how to add an I8 and an option I8 because they're different types. When we have a value of type like I8 in Rust, the compiler ensures that we always have valid value. If we see confidently, we have to check for null before using the value. And only when we have an option I8, we have to worry about not having a value, and the compiler will make sure that handle the case before using the value. In other words, you have to convert an option t to a t before you can perform t operations with it. Generally, this helps catch one of the most common issues with null, assuming that something isn't null when it actually is. Eliminating the risk of incorrect assuming a not null value helps you to be more confident in your code. In order to have a value that can possibly be null, you must explicitly opt in by making the option type value t. Option t. Then, when you use the value, you are required to explicitly handle the case when the value is null. Everything that has a type that is an option t, you can safely assume that the value isn't null. This was deliberate designer decision for Rust to limit null's pervasiveness and increase the safety of Rust code. So how do you get t value of some variant when you have a value of type option t? So you can use the value. The option t enum has a large number of methods that are useful in a variety of situations. You can check them out in the documentation. Become familiar with them. Ninja, okay. I don't need the advice. The match flow. Speaking of coins, that's an example of using match. We can write a function that takes an unknown US coin. In a similar way, the counting machine determines which coin is it and returns it by using send. Enum values in send. I've shown this at the beginning. So you take a coin and match it up. Coin, penny, coin, yeah. Let's break down matching the value. First, we list the match keyword followed by an expression, which is the case, and the value, well, whatever. You will check, this is a switch case. Match coin. It can also be a block. So nothing surprising here. Let's imagine a friend is trying to collect all 50 quarters. We should lose change by coin type. In the match expression for this code, we add a variable state to the part in the match values of the current coin. When a coin quarter matches, the state variable will be bind to the value of quarters. But we can use state in the code for and like so. Well, I mean, yeah, these are enums. Nothing surprising here. Matching with option T. In the previous section, we wanted to get the inner T value. Some case in using option T. We can also have option T using match. As we did with the coin enum, instead of comparing coins, we compare the variant option T. By the way, the match expression works remains the same. So match is non-sum. Yeah, so this is usually the idea that goes behind Rust. I see a lot of people that you simply check for something, and if it's not none, you go. Yeah, also the +1 to none will do nothing, so that's good. So, does sum match 5 some I? It does. We have some variant. The I binds to the value containing sum, so it takes the value 5. Because is the match arm is then executed, so we add one value to I, located some value with out of 6. Now let's consider the second call of the plus. Existing where is none, we enter the match and compare none. It's matched, there's no value to add to, so the program stops and returns the non value of the right side of a equal bigger. Because the first time match, no other compared. Combining match names is very useful, yeah. Matches are exhaustive. There's another aspect of match we need to discuss. The ARM pattern must cover all possibilities. Consider the version of +1, which has a bug and won't compile. Okay, so you have to get everything done. Catch all patterns and the placeholders. Dice roll 3, 7, other. Here we go to take special action. For a few particular values, but for all the other values, take a default 1 action. But this ain't enum. Of each player. Okay, so you basically change everything. Yes. Yeah. Okay, so that's done. Now wait a second. Concise control. Go with if else. If let syntax lets you combine if and let in a less verbose. Wait, hold on, why is that you want pattern? Why ignoring the rest? Listing. Okay. Let config match. Config sum and everything else. It's why in sum we print out the value in sum. We have to do anything non-value. Satisfy the match expression, we have to add. The process is just one value, which is annoying, but I to add. So we can write a shorthand. If less sum max, configure max println. If let takes a pattern and an expression separated by an equal sign. It works the same way as a match when an expression is given. So match the pattern. Its first arm, in this case, the pattern is sum max. Okay, with if let I can pattern match without the boilerplate. Good to know. Alright, define a few type of messages used below. Which would be motherfucker. You gotta be kidding me. Looks good. Right, so point x and y, good. Define the different variants used below. So move, echo, move, point, echo, string, change color. It's some either disuse or use sizes, and quit as nothing, just a type. Oh, message. Message dot resides. Yeah, so that I remember that. Missing structure field 0 and 1. So you want to struct that tuple. So struct dimensions. I32. Ay, mamacita. God damn it. Dimensions. Okay. Oh, I can define it in place. Okay, there we go. So we define the struct inside over here. Yeah, this is where Rust gets a little bit confusing, so good. I got what I want. The point was to suffer this year, as I did last year. But that's beside the point. I wish to finish 2033 because I started with Golang and it was nice. It just got stuck on one exercise and I don't want help. Hope this year I get further. I mean, I want to finish it anyway. So in January I'm gonna keep going, but if I get stuck, I'm gonna cry a lot. So struct point. That's fine. There's the message and there's the state. Struct. State has a lot of stuff, and there's the process. Create a match expression to process different messages. Variant using a message defined above. So the match not here. Give me the meat. So match message little baby arrow, and then we can message. Actually, let's pick this up. And then we can add some stuff. First, so use of undeclared class or method message. Oh, my bad. Okay, we're going places. So, what do we do now? Yes, we can return a resides. Let's say resides. Messenger size, not a unit structure. It doesn't return dick, right? Okay, this might be the harder one. Okay, move would be return a point. Well, I'm getting my ass kicked over here. Can I implement anything that works? Literally anything. Echo is a string. I can do a string. Body, we ain't going far. Brother. You gotta be kidding me. Expect unique struct, unit variant, or unique constant found, tuple variant, message echo. And this is what I wanted to do in the first place. But it still got mad. The unique struct of cost found the tuple variant of message echo. Use the tuple pattern by instead of the message echo. The fuck is the tuple variable, bro? So match x, none is none, sum is sum. So I'm matching whatever is this, the message. Yeah. Variants using the methods before. So shouldn't this be self.echo? Try me. Oh my god, yes. So he wanted also the whatever the fuck it takes in. I see. And I hate it already. So message resides. Yeah, this one goes for last. This should be just wait. Is that? Good. Change color. Shouldn't be too hard. But the change color once you wait. This will be RGB. Change. One. It was underscore for everything else. Nice. All right, but before that, allow me to understand how this works. So I'm guessing this should be called, let's say, a point and point. So I have to move. And the boss fight resides. This stuff is a little bit confusing, but I'm guessing should be some lines like speed, height, self dot resides 1 and 2. Expected tuple variant found abstract by message resize. Not a tuple sub or tuple variant. Maybe, just a maybe in this case, we don't need this. I'm calm. I'm very mad, but I'm calm. Yeah, I'm taking the help for this. Son of a bitch, no, I don't need this bullshit. This is a... Because this is not a method, so... Structs inside... Structs inside the enums. How do I pattern match this stupid shit? Oh, alright, move. Fancy stuff. Pattern match a struct find enum rust. Don't you dare give me the base cause okay, life A Live I ate. Live. Live. Okay. So progress is progress. At least we fail somewhere. What's the big deal here? Guessing this shouldn't be random, right? Ten 30, 10 15. Wait a second. Well, the compiler is getting me places. Places. So that's good. Somewhere we are getting led to. What's the next magic? Magic stuff, magic man. Fix the compiler error with the signature. So we have a let current favorite color. Print my current favorite colors here. Mismatch. Expected string found str. This is because this bad boy here is not a string, but a primitive. Number 2. Fix the compiler error in main function without changing this function. This returns a bool. Arguments of this function are incorrect, such that the expected string str found string. So we delete till my bracket and delete this thing as well. After pattern matching, this is child play. Remove white space from both ends of a string. Add word to the string. Replace cars in the string. So first one would be remove white spaces from both ends of the string. Well, that's more interesting. Can I iterate over string? Cars. This is the good stuff. So for IC in input dot cars and enumerate them. Great. Now should be let's starting index EU sides ending index, which is also U sides, and if car if C equals space starting index yeah, well, that doesn't work, does it? Because I don't know when I'm getting this. Well, actually should be the first one that's not. Let's make it stupid. Oops. If the character is not an empty space, then starting index should be I minus 1. Also break. Because we're here. Now the next cool stuff is if C is equal to space, but at the same time I is different than starting index. Then ending index is I. Break. Now it's time to slice a string. Okay, so this would be starting index, ending index. Or was it something like that? Expect value found built-in type string, not a value. So let's initialize it. Should be cannot mutate immutable variable, of course. Così assigning by 42. And return value reference local variable as return a value referencing data owned by the current function. Yeah, bro, I'm trying, but you won't let me. Like, come on. Like, can I return the string itself? Wait, it's input. I stupid. Okay, it compiles. Might not work, but it compiles. Add word to the string. There are multiple ways to do this. Can I concat the string from input plus world? Actually, oh wait, it works. Well, damn. Replace cars with balloons. Replace from cars to balloons. So trim fails, but I'm guessing I can make it less stupid. Because I could like remove. Well, glad I rocked it like the old good old days for no reason. Shit's getting tiresome, not gonna lie. Alright, big boy. What is the deal? Last stuff. Lots of shit. Calls of this function should be placed with calls of string, slice, or string. Print args, print args. A bunch of values. Some are string, some are str. Let us replace placeholder with either string, slice, or string. So blue should be string, slice. Red to string. Let's read the type, so it's a string. Obvious string. to owned. Into. The fuck? Format. Trim, we see already it's a slice. String slice. Copy on the replace, that's a string. To lowercase. I'm saying that that's basically a string. Oh yeah, that's good. Now, how many modules are modules? Mod. Is this like a namespace? Probably. I think this is the last thing we're doing today. Shit hits hard. Modules. Dude, it's right in front of me. See, today I'm not in me today. I'm not gonna be. Thankfully, tomorrow there's no stream, but Sunday there is. I'm gonna be as tired as today. I didn't have my coffee. Finished it as of this morning. Managing growing project packages and crates. Yes, give me the meat. Showcase and libraries. Pub mod garden. Yeah, so this is namespaces. I see that. Don't let anybody outside of this module to see this. Ooh. Private. Nope. So there's the pub. Pub. Private. So yeah, it's implicit. You can bring module paths into scope and provide the new names for them with the use and as. Provide paths into scopes and provide names for them, the use and as. Add the following to instead after fixing them. Use self fruit pair as and as. Okay, so this is a module and I could export it here. Actually, let's bring them out. Pair as fruit. this as veggie. Okay. I'm going to use statements after fixing them. So once again, Rust has a quite sane choice. By default, methods are private. And the final one for today, because I am tired, works at 8. Today I wanted to stream till 9, but shit got cluttered, so we're doing what we can. So let's try to enjoy our last stuff of the day. You can use the use word to bring module paths from modules from anywhere, and especially from the library you're into scope. Bring system time and Unix epoch from the standard time module into your scope. Bonus style points if you can do it with one line. Use. So match system time now duration since Unix epoch. Use standard time Unix epoch. Okay, I see. So this is the not stylish solution. What is now? Well. Well, thanks for anyone who's here. Today was a blast. It went, I believe, better than yesterday. Tomorrow we are checking the hash maps. So halfway there. And had a lot of fun. As per usual, have a nice day. Bye.